Dear friends, welcome to my video on quantum physics definition of energy. Kindly click on the CC button for subtitles. A quick refresher on energy before we dive into the deep quantum waters. Let's take a quick refresher swim in the shallow end. In classical physics, the stuff we learned in school, energy is the ability to do work. Simple, right? Whether it's a ball rolling down a hill or the sun shining on our planet, energy is what makes things move and change. Into the quantum deep end now, let's venture into the quantum realm. Things get a bit wackier here. At the tiniest scales, energy isn't just a continuous flow. Instead, it's transferred in tiny, discrete packets called quanta. The smallest of these energy packets is called a quantum. The legend of Planck's constant, a German dude named Max Planck, was the first to throw this curveball. He found that the energy, E, of a quantum is proportional to its frequency, F. The proportionality constant is known as Planck's constant, h. The formula goes something like E equals h times F. Planck's constant is a teeny tiny number, roughly 6.6260701 times 10 to the power of negative 34 joule-seconds. But don't let its size fool you. It's one of the most critical constants in quantum mechanics. The energetic dance of particles at the quantum level, particles like electrons in an atom don't just have any energy they like. They can only exist in specific energy levels. Picture this as a nightclub where dancers, particles, can only dance on specific, well-defined floors. No in-betweens allowed. When an electron jumps from a higher energy floor to a lower one, it releases energy in the form of a photon, a particle of light. This is how neon lights or fireworks get their vibrant colors. Each color corresponds to a specific energy difference between electron floors. The uncertainty principle, the universe's rule of mystery. Werner Heisenberg, another cool quantum physicist, introduced a concept that truly boggles the mind. He stated that you can never simultaneously know the exact position and momentum of a particle. The more precisely you know one, the less you know the other. This isn't due to some technical limitation, it's a fundamental property of the universe. So, when talking about energy at the quantum level, there's always a bit of fuzziness involved. This fuzziness, or uncertainty, isn't just a challenge for scientists, it's the universe's way of keeping some cards close to its chest. Entanglement, the ultimate quantum relationship. Let's talk about one of the most mind-bending phenomena in quantum physics, entanglement. Imagine two particles that become intertwined in such a way that the state of one particle instantly affects the state of the other, no matter the distance between them. They could be light years apart, and yet, they'd remain connected. This spooky action at a distance, as Einstein called it, suggests that the very fabric of space and time is interconnected in ways we're only beginning to understand. The energy of entangled particles is so deeply interdependent that they unveil a profound layer of unity in the universe. A world of possibilities and probabilities in the quantum realm. Things aren't deterministic as they often seem in the classical world. Instead, everything operates based on probabilities. An electron, for instance, doesn't have a definite position until we observe it. Until then, it exists in a superposition, a combination of all possible states. It's like the universe saying, I won't decide until you look. This fundamentally changes our understanding of reality and the role of consciousness in shaping our experiences. Final thoughts. What's next for quantum understanding? Quantum physics has redefined our understanding of energy and the universe. We've come a long way since the days of classical physics, uncovering layer after layer of the deep mysteries that govern our world. And as we unveil each layer, we discover even more questions waiting to be answered. In many ways, the quantum realm reminds us of the vastness of the unknown, urging us to stay curious and continue exploring. Who knows what other mysteries await? One thing's for sure, the adventure is far from over. And there you have it, a casual trip through the intriguing world of quantum energy. I hope it sparked your curiosity as much as it does mine. Thank you for watching my video. Kindly subscribe to my YouTube channel and give a thumbs up. Thanks for your support.